All right, let's talk about the effective interest rate. This is also known as APY. Okay, so you might see that terminology used, and it stands for the annual percent yield. Okay. Now, what it is, the effective interest rate is the simple interest rate that would produce the same amount in 1 year as the nominal interest rate compounded m times per year. Okay, where m is the number of conversion periods. So it's an equivalent in interest rate. So it's the equivalent interest rate that would give you this the equivalent simple interest rate that would produce the same amount in 1 year as the compound interest does. So it's important to know that APR and APY are not the same thing. APY is often used when when somebody's trying to sell you an investment, because APY tends to look higher because it takes a higher interest rate when you have simple interest than when you have compound interest to earn the same amount of money. So in general, APY or effective interest rate looks higher. So if you're investing, they want you to think there's a higher number there, right? APR is a little lower and is used mostly for like if you're going to borrow money, then they want to give you an interest rate that looks lower. But APR and APY are not the same thing. All right, so let's figure out how to calculate the effective interest rate for a particular investment. All right, so first of all, in the definition of the effective interest rate, it's the interest rate that would produce the same amount in 1 year. So we're gonna first of all let t equal 1. Okay, so it's just gonna be 1 year. All right, and let's look at our simple interest formula. Our simple interest is this formula. The formula is A equals P plus or times 1 plus the rate times the time. Okay. Now this is the rate that we're looking for. We're looking for the simple interest rate, right? That would produce the same amount in 1 year as the nominal compounded interest rate. Okay, so this is actually the interest rate that we're looking for. So I'm going to call that R sub EFF, okay, for effective interest rate. Now again, our T is 1 year, so I'm just going to, anything times 1 is the same, so I'm just going to leave that off. Okay, so essentially this is the accumulated amount after 1 year at some simple interest rate that we're looking for. And our compound interest formula is A is equal to, I suppose I should make that a colon. All right. A is equal to P times 1 plus R over M to the MT, but T is 1. T is 1 still, right? We said let T equal 1 because that's the definition of the effective interest rate. Okay. And what we're going to do is just set these amounts equal to each other, right? Because the simple interest or the effective interest rate is the simple interest rate that would give you the same amount in 1 year as the nominal rate over 1 year. Okay. With M compounding periods. So we're just going to take these two formulas and set them equal to each other. So we have P times 1 plus the effective interest rate, which is what we want to solve for, is equal to P times 1 plus R over M to the M. Okay? And now we need to solve for the effective interest rate. Well, we can divide both sides by P, right? So I can do that. And then I'm just going to subtract 1 from both sides. Right? So what I end up with is the effective interest rate. After I subtract 1 from both sides, I just get 1 plus R over M to the M power minus 1. And that's all there is to it. Okay, so let's summarize what we just said here. The effective interest rate is equal to 1 plus r over m to the m minus 1. Okay, and then we can define our variables here. All right, so this r sub EFF is the effective interest rate. The lowercase r is the nominal interest rate, and m is the number of conversion periods per year. All right, now let's look at example 5. Let me leave that formula up here as long as I can for the effective interest rate, because we're going to calculate some effective interest rates corresponding to a number of different compounding periods. All right, so we're looking for the nominal. We've got a nominal rate of 4% per year, and we want the effective interest rate if it's compounded annually. So the effective interest rate, okay, we're just going to use that formula. 1 plus 0.04. Now it's r over m. In this case, m is equal to 1 if it's compounded annually. So it's going to be 0.04 over 1 to the first power, m is 1, minus 1. All right, so this one's pretty straightforward. All you really have is 1.04 minus 1, so we end up with 0.04, which is 4%. Okay, so really if we're just compounding annually, the effective interest rate is just that. So all right, so let's look at a little more interesting case. Let's say we're compounding semi-annually. All right, let me see if I can I'll just keep that up there as long as I can, I guess. The effective interest rate is equal to 1 plus r over m, 0.04. But in this case, we're compounding semi-annually, so m is 2. And then to the m power, which is 2, minus 1. Okay. Put that in your calculator. What do you get? You get 0.0404. So, or as a percentage, it would be 4.04%. All right. What if we compound quarterly? What's the effective interest rate? All right, let's take a look at that. So the effective interest rate is 1 plus 0.04. This time we're compounding quarterly, so m is 4. We're going to raise that to the 4th power and subtract 1. And what do we get? 0.0406. All right, so 4.06%. How about monthly? If we compound monthly, the effective interest rate is equal to 1 plus r, 0.04 over m, which is now 12, and 12 months per year, so m is 12, then minus 1. So what do I get? 0.04074 now. Okay, so talking about 4.074% is the effective interest rate. Okay, so that's the equivalent interest rate you would have to earn if you were earning simple interest, right, to get the same amount that you would get by investing at a rate investing in an investment that paid compound interest monthly. Okay. All right, one more. Let's look at daily. The effective interest rate, compounding daily. So now our m is 365. So 1 plus 0.04 over 365 to 365 minus 1. We get 0.04081. So 4.081%. All right. So the effective interest rate, if the effective interest rate is known, then the accumulated amount after t years can be more readily computed by using this formula, right? We can just essentially find the amount. If we know the effective interest rate, we can find the amount accumulated after t years by taking the principal times 1 plus the effective interest rate to the t power. All right. So So it makes a calculation a little simpler if we know the effective interest rate to figure out how much we're going to have um, at the end of a certain term. All right, so that's all I have for this video. I'll meet you in the next one.